Internet of Things, enhancing smart IoT applications using advanced processors. It is my immense pleasure to introduce the resource person for today's session, Dr.S.Thayammal ma'am, Associate Professor, Department of VCE, P.S.R. Engineering College, Sivakasi. Dr.S.Thayammal ma'am has completed his PhD in the specialization of Information and Communication Engineering from Anna University, Chennai in the year of 2018. She has 14 years of teaching experience and 10 years of research experience in the area of image compression, pacifying transforms. She actively participated 35 workshops, seminars, STTP program and presented, published 14 national and international conferences. She published her research work in 9 international journals. She organized international conferences and Anna University funded 2-week FDP on linear integrator circuits. Also, she organized 5 workshops and 8 seminars to faculty members and students. She is one of the peer reviewer of 3 reputed international journals and 1 international conference organized by Kalasalingam Academy of Research and Education. Dedicated, resourceful and professional educator with a solid commitment to the academic growth and development of every student in the class. Competently guided UG and PG students through their project work. Skilled in adapting to students' diverse learning styles. She passionate towards academics and research. Her academic research interests are signal processing, IoT, AI, machine learning, deep learning, keeping in touch with all the latest developments in AI technology. She is a lifetime member of IST and IEEE. So we are privileged to have the resource person like Dr.S.Thayammal ma'am to deliver an expert lecture in the field of IoT. Welcome you, ma'am.
Thank you. Thank you for your wonderful introduction.
Thank you, ma'am. Ma'am, let me make you as a presenter and then you can start sharing.
Sure.
Yeah, ma'am, now you can present, ma'am.
Sure. Is it visible, Krishna Kumari?
Yes, ma'am. Yes, ma'am, your screen is visible, ma'am.
Visible, okay.
Thank you.
Okay, very good afternoon to all of you. First of all, I would like to thank the management of P.S.R. Engineering College. There are Solid Chani, correspondent, and the director, Mrs. Vigneswari Arun Kumar, and the chairperson of that this program, Dr. Narendra, who is head of the Department of VCE, and the coordinators for giving this opportunity. Today, I am going to discuss IoT data management, particularly data aggregation and data dissemination. So these are all the contents I am going to discuss. The introduction. In that introduction, we are going to see the basic elements as well as the processing steps involved in IoT system, and what are the advantages in IoT, and what are the challenges in IoT, and particularly why the importance in data management. Both the data dissemination and aggregation, both are combined under the umbrella of data management. So generally this IoT, we know that IoT stands for Internet of Things, which just interact with the smart objects. That smart objects are sensors, hardware and software. So apart from this, now the smart objects means we are including the new technology to this IoT. Example, AI. Okay. So here I given some present a few applications for IoT, that is wearables, transportations in smart home as well as smart city also we can do. The IoT plays an important role for retail, insurance, healthcare, agriculture, industrial automation. Not only this, Okay. So wherever we have the internet, there the IoT plays a role. So here, if you take the wearables, so the wearable means nowadays we have the smartwatch for getting calories while we walk. We use that digital watch, that is smartwatch. It automatically give how much calories we can uh, actually we uh, reduce, the energy is reduced by using. Hello. I think some disturbance is there. Is it audible, Krishna Kumari?
Yeah, yes, ma'am. This is audible, ma'am.
Okay, okay. I think some disturbance is there, so that's why. Okay, thank you. So the in that wearables means the example of that wearables application means smartwatch. So so what happened means if, for example, if we apply the AI for this in this wearable application, for example, this smartwatch means. So in existing smartwatch, even though if we wear that, just we have that watch in the hand, and if we walk, it also calculate the calories. Suppose if we wear watch and also told that watch and we move into the car or two-wheeler, that is also calculating the calories. Okay, it doesn't know whether we are walking or not. Okay, it's just calculating the distance like that. Okay, so if we apply the AI, it actually find out whether actually we are walking or not, or we are moving with some other transportations. Okay, so that's why we need to apply AI now. The AI technology into that IoT is the very powerful technology to be better than that existing IoT. And then transportation is also, if you want for example, I told that for each and everything I given an example. For the transportations we can easily find out if nowadays if we book any train ticket or bus ticket, we can find out the where actually at that particular time where it is. Okay, depending upon that we can route map. Actually we can find out in which time it reach our point, our picking point. Like that we can find out. So that is kind of IoT. And then for smart home and smart city application, this is very in central government organization, they giving uh, a fund for smart city infrastructure. And then for smart home, in that smart home, in that existing IoT, that is without applying this new AI technology, the existing IoT application, what it actually done means it just find out, for example, within the room, we need to use that light, that is light, and then air. Okay, depending upon, we need to use light sensor and air sensor, gas sensor. Okay, not gas, air sensor, how much that is depending upon humidity sensor, we can find out actually whether the room is very hot or not, like that. Okay. So in earlier IoT, in that sensors, the temperature, just to find out what's the actual temperature. If we want to reduce that sensor, depending upon that sensor value, it automatically switch on that fan, or otherwise switch on that air cooler, like that, air cooler or AC, whatever. We want to reduce that temperature, we can use in that IoT automatically on off. That is also possible with this IoT. Okay. If suppose if we apply AI in that means, depending upon number of people enter into the room, as well as how many uh, peoples are occupying in that room, and for that people how much we need to maintain the temperature, and that is also need to include. Suppose if the temperature increase depending upon any unavoidable situations, not for actual temperature reading. Suppose someone used that any stick, a matchstick, it automatically find out the temperature is increased. So, what happened? The AC, that is temperature, will reduce by using any either increasing the fan speed or AC reduce the temperature in the AC, like that we are to. If you use AI, it actually what it done means as a human, what we think, okay, like that. So it needs to that IoT system should have visual as well as visual system. That is very important. Okay. So that is nowadays the IoT with AI is the very demanding research area. And then next is smart home, smart city. We know that retail. We know that depending upon customers and all those things, insurance, health care, for heartbeat rate, for many measurements in our body. We can use that IoT application in agriculture. Recently, many even even the IoT is implemented nearby our villages also. Just they used by using that IoT applications to find out the humidity, what is the water level in that area. So just by using that IoT infrastructure, they can easily find out the weather condition in that farming area, and depending upon that, they go to the field and do the necessary action. And then industrial automation. This is very limited only in automobile. The infotainment car, the infotainment is very important. We use that infotainment. There is also enhancement in that infotainment is also is in under the developing thing. So in that, what actually that enhancement in infotainment means, just they try to make the screen, the laptop screen or our mobile screen into car glass. So that is that actually interdisciplinary research that is belongs to materials related to mechanical department also. So these are all new technologies, or not only the single department, this interdisciplinary thing. Okay, so just they have to use, just we can, if it will be successful, then we can easily work with that. Just instead of using this small screen, we can use our car glass as screen for our purpose. Just to, and one more, there is also some difficulties will be there in order to touch that screen. Just if you want to read any other information at that time, you can easily use that screen for that, depending upon purpose that will be changed. Okay, so each and every technology have pros and cons. So these are the some of the applications in IoT. So the change in technology, I already told that a change in technology means we have to import the new technology to that IoT. So it needs to face some challenges, major challenges to get out structural imbalances. Okay, so if you want to get more data, then automatically we need to include additional sensors, otherwise we need to uh, change the design and specification of this sensors. Okay, either we need to increase the sensors, or we need to improve the capability of the sensors, and we need to manage with the operational cost. The system must be executed with the balanced risk as well as high data availability. When we increase the number of sensors, okay, automatically the data availability will be increased. So these are the major challenges when the IoT is imported with some new technology. And as well as we need to face the challenge, the process of unstructured data. This unstructured data means, for example, the numbers, there is temperature value, all those things are unstructured data only. So this unstructured data we need to process with that. That is also major challenge to this. And as well as interdisciplinary data processing means the IoT system must incorporate all those interdisciplinary data processing. For example, the same that link, that is the same gateway which occupy different data from different sources which belongs to different applications. So the information, the data is from hospital, the data is from agriculture, all those data are combined together. So that IoT infrastructure must facilitate that interdisciplinary data processing and then scalability and then affordability. So these are all the major challenges when we import the new technology to this IoT. So, so in this one, just the IoT is works with anything, anytime, anywhere. So here the anything is nothing but the application. We can any for any application we can use this IoT. So that is the anything. Any time means it may be, for example, real time data. Each and every time, if the patient is very sick, means we need to observe each and every time we need to observe the data. That is real time data. Suppose if you want to maintain the patient conditions, so if he is normal person, if suppose the for example sugar is increased, sugar level is increased above 120, automatically need to intimate, means at that time it is not necessary to display each and every time the sugar level. When it is exceed 120 dot, so that is also any time. Okay, that is actually not real time. Real time means then and there it will go to the end users. Okay. uh, so anytime means the data can be processed either in batches or real times or streams. So batch means a set of data of for particular time need to send data. So like that. Okay, anywhere means it may be a hospital or it may be a agriculture area. So anywhere, anytime, any applications, anything. So this IoT works on that based on anything, anytime, anywhere principle. Okay, and next we are going to discuss the important blocks and then process steps in that IoT system. So these are all the five blocks included in that IoT environment. Sensors, this is also called as actuators, and then data acquisition system and internet gateway, edge IT, that is edge computing, cloud and data center, and then finally end user. So here, so these are all the schematic diagram for this processing steps as well as basic elements in IoT infrastructure and IoT environment. The first one is sensors. So that is this is used to acquire the data. So the sensor it measure or recognize or qualifying or quantifying. So that informations, that data are acquired by these sensors and then it is moved to the data acquisition system or that gateway. So it do that sensor data into meaningful information. Okay, it converts analog to digital. If it is depend, the sensors are also different classifications out there. Okay, there are different almost five different classifications are there. Okay, so if it is analog, we need to convert that into digital conversion. If the data is analog means then need to convert into digital sensors are so that, so at that time it is not necessary to convert that into digital by means. Next, edge IT. This is edge computing. This is very important block. It plays vital role in that IoT environment. Here, data filtering and data analytics. So the accurate data or sensed data before going to the cloud. It need to do some operation. It analyze, and in this block only the redundant or unwanted informations are eliminated. Okay, So all these process, the filtering is nothing but unwanted information, won't be record informations only. For example, for that patient, already I told that if the patient monitoring based on this IoT environment means each and every time the informations are goes to that end user, to the doctor. Okay, so for particular time, it in that edge ID actually it have this computation. We need to maintain that sugar level pressure within the threshold level. If it is exceed, if that exceed means then automatically it goes to the end user. Otherwise, if repeated information for 1 hour, the sugar level is not changed that much means 80, 82, 80, 82 means that redundant informations are filtered in this block. Okay, only required information, that is meaningful informations only go to the next step because of this edge computing. Okay, data analytics, that is also very important role here. Okay, so this block is very important in this IoT environment. And then after doing all the filtering process as well as analytic process, the exact, that is meaningful informations are stored or transferred to the cloud. If that data is only accessed by the end user when they want means just the data is stored, or otherwise the data is directly moved to the end user. Okay, so here data dissemination and data aggregation. So that is very important. Data aggregation means from the sensors. From the sensor, there are, we told that different sensors out there. How the sensors are different sensors as well as they connected in different manner. Virtually, connected in different manner. So how we get that data from that sensor? Okay, so that methodology, that thing is belongs to this data aggregation. And then data dissemination is also there. So in that cloud we have number of data, so how we can disseminate to the end user. So here for simplicity we put a end user is single end user, but actually there are number of end users are there. From the cloud, how we can disseminate, how we distribute the exact user, the particular data to this user, like that. Okay, so this data aggregation and the data dissemination plays important role. So this topic only we are going to discuss. So these are all the information already I shared, that is sensors and actuators. This is the, it is just a source for that IoT. And then here the sources are, the data source, the sensors are categorized as active, passive and a dynamic source. Active source depending upon how it starts to sense. Okay, active sensors means automatically it is sense. Passive means after giving some impulse, after making them sense to sense, and then only it starts to sense. Okay, dynamic means it do both the things, as well as these dynamic sources, dynamic sensors. This is it have the capability to transmit as well as receive the data. This is very important kind of source. Okay, so also depending upon the produced data, whether it is analog or digital, there are analog as well as digital sensors are there. So totally there are 5 different types of sensors. It is act as their sources for this IoT applications. So the data acquisition system and the internet gateway. So this data acquisition system, that here the sensors generated the data and that are aggregated, that is that are combined and converted into digital form. See, so the aggregated, the collected data are converted to digital by means of this data acquisition system. So this plays important role in that IoT environment. Okay, so before going to that, it will fed to the edge computing. So the internet gateway is connected to the edge by means of either internet or Wi-Fi or Bluetooth and LAN. Okay. the edge computing. So the edge computing after data aggregation, that is after that gateway data acquisition system, we need to, before going to that cloud, it needs to do some process. Before reaching the cloud, we need to do some process on that acquired data. Here, this edge IT, that is edge computing, performs necessary data processing as well as analysis. Okay, so actually this edge IT is placed near to the sensors only. Okay, and then without this edge, if we didn't use this edge computing, means automatically we need more number of resources, that is abundant resources, that is capacity, storage, security issues uh, will import in that cloud. Okay, if we have edge IT, that is edge computing in this near to sensors, near to sources, then it is feasible. Okay, so nowadays we use like that only. So before moving to the cloud, in that edge IT, it do all the filtering as well as analysis process. If we didn't, without edge IT system, the data center need abundant resources. The resources like bandwidth, capacity, and security issues, storage, that is big issue in that cloud. Okay. And also it causes delay in that data process. If all the process do in that cloud, means it takes more time. Okay. Hence, the edge IT, it is the pre-process the data into meaningful information. So this is just for example. If we want to send the water quality data directly to the data center, instead of sending all information, that is quality information, to the cloud, just we analyze what are all the impurity level present, that is pH level, what is the pH level to that water, directly given that information, that is enough. Instead of sending each and every data water quality level to the cloud, just we need, it is enough to send what is the pH level of that water. Okay, if it is above 7, automatically there is not normal water. So that analysis, that kind of analysis is done in by means of edge computing. Now, cloud and data center. This is a very if you think here lot of organization as well as share is there. Okay, cloud we can use that. We have each there are different vendors for this cloud. Okay, we can use either by paying, if you want depending upon that, if you want if you want maintain our data in very secure manner, means we need to pay some amount for getting cloud area. Okay, is the core idea of the IoT environment. Okay. So the demand for this network resources for this is reduced by decentralized model. Decentralized model is nothing but edge computing. Centralized model, if we use cloud as the centralized model, means then we need to the cloud itself will have all those filtering as well as analysis thing. If it is decentralized, means separately edge computing is present there. And then cloud is used to store data more securely, and then this data center, it is perform the depth process of the data and analyze it from various sensors. The depth processing, data analytics will be detailed data analysis will be done in the cloud, in the data center. So this data center is used to manage the data for further transmission as well as dissemination to the further travel, or otherwise it is stored itself. And in that if we want for further in later on we need the data, means just that informations are stored for further retrieval process. And the end users maybe if it is real time, means each and every time the users get access from the cloud, or otherwise if it is not in the case, If it is only it exceeds the particular threshold value, that intimation only required means at that time it is not required. For example, if we used a smart home means just to be went to the outside, that is it went um, our workplace, but actually there is any electrical appliances unnecessarily in the on condition means at that time just it want to intimate us. Okay, so that is at that time when unnecessarily that any appliance is on in the operation, so at that time only that IoT need to give information to us. So every time it is not necessary to give the information regarding that. So that is very important thing. And this that is the optional phase only. So that's why. So it's not compulsory one in the end user. Here, each and every block, not only this, in this one, each and every blocks belongs to huge research thrust area. Okay, if you consider the sensors, that is physics as well as electronics department, okay, the sensors design specifications are very important, crucial role. Okay, sensor design and then data acquisition system. The sensors in case not only the temperature sensor, gas sensor, like that. Apart from that, our camera, that is also kind of sensor. That is the elements or the components which are used to acquire or sense the target object. Okay, so that is sensors. And then data acquisition system, that is data gateway. So in that one, how, what are the possibility we get, that is we acquire the data, that is we collect the data. So the collection of the data plays important role. So depending upon how we interconnect the sensors, in what topology we connect the sensors and collect the data from those sensors, that is important. That is also plays important role in the IoT lifetime, the whole environment lifetime, because the sensor's lifetime is depending upon power consumption as well as the durability, how frequently it makes the sense, how frequently it needs to take sense. Okay, so that all are responsible for the sensor lifetime. If the sense depending each and every block plays important role for this lifetime of the whole IoT environment. So among this, the sensors, from the sensors, the data collection, they plays a crucial role in the lifetime of the IoT environment. In this edge IT, so it's nothing but data analysis, data science, that it plays very, that is also recent technology in this decade, data science. So in that data science, we need to again implement the new technology, machine learning, AI, deep learning, all this new technology we can place in that HIT. So that's why I told each and every block there are lot of challenges are there, as well as it is not only the particular department. So combining all those departments, we can get the final thing. Okay. So in that cloud, the cloud only full and full core IT department. So the remaining things are interdisciplinary only. So that each and every blocks, it is belongs to the lot of research work have been developed, as well as ongoing research demand is also there in that IoT building blocks. So there is very important IoT here for creating that environment in an isotropic environment, aggregation, processing and dissemination. Focus on the data needs to be improved. On isotropic means we need to concentrate on particular. It is not for all the things. It need to it to do for the particular environment, that is very confined environment. It need to improve the processing as well as aggregation dissemination process also. Okay, so in that one, the data management, how we collect the data and how we can distribute the data from the cloud. That is dissemination, data aggregation, processing, and dissemination. Aggregation is the collection of data from the sensors or actuators, processing, that is edge IT as well as cloud data center, and then dissemination means finally distribute to the end users. So all these are these are data aggregation, data analysis, and the dissemination. These all are play significant role in the data management of the IoT environment. Okay. So the generally the data environment is not only belongs to that data analysis, it is also depending upon how we collect and how we disseminate, how we distribute that data to the end user. These are the challenges and issues in that IoT. Security issues. So for that IoT can be hacked. That environment, the data in that IoT can be hacked. So we need to need the security in the stack, and then privacy. Privacy is also important. That is private information that is also possible to stolen. And then complexity, when we increase the devices as well as when we the importance of IoT in particular applications, that is also plays important role in complexity. Okay, they related depending upon that application, it will relate to need to use hardware as well as software technology. So that is also plays in the important role in the increased complexity. And then compatibility. Compatibility is how compared with the existing hardware as well as software. If, for example, if we use a software with the hardware, for example, agricultural applications, we used software, the controller, Arduino controller with its own software. Okay, if you want to update further information, is it necessary to replace hardware or software or both? So that is important thinking IoT environment. Okay, so if you want to enhance, if you want to find, if you want to include additional parameters to sense, means automatically we need to change. That is called as structural changes. Okay, that is physical structure change, as well as we need to change that program also. In order to get new parameter, sense new parameter, we need to change all those things. So that compatibility issue is also one of the big challenge in the IoT. It is not in the case of in case of digital signal processor. In the digital signal processor, compatibility is exist. If you want change, for example, in that DSP processor, we have the software, that we have the program for filter design. Okay, for example, we write the program for to second order low pass filter. If we want second order high pass filter, means just we need to change that. If you want include fourth order low pass filter, means instead of n is equal to 2, n is equal to 4. Like that we need to put. No need to change all those programs. No need to change any hardware at all. Just in the program, in that program, just we need to change that variable corresponding to that variable n is equal to 2, n is equal to 4. Need to change like that only. That is compatibility. But in case of here, if you want to change additional things, if you want to enhance that existing environments, we need to totally change that. That is one of the big issue in that IoT. So that information is only here mentioned. Next, in that data management is management life cycle. Actually, this belongs to three blocks. That is data aggregation. It is combination of decentralized data center, that is edge computing, with the cloud and the data center, combination of those two, and then finally the data dissemination. All these are combinedly called as data management. In that one, data dissemination and data aggregation plays important role in that IoT life cycle, IoT lifetime, that whole environment lifetime. Here, in that data management, these are all the steps in that life cycle, data management life cycle. These are all the steps involved in that data collection, data process, data storage and secure, data usage, data sharing and communicating, data achieving, reuse or restoring that data. So we know that from the data collections, the data are acquired from the sensors, and after that we need to do some process, pre-processing step, filtering process, like that we need to do by using this stage, and then storage and the secure. This is in the case of cloud storage, and then data usage, how we use in the end user. We need to share data usage means in that cloud as well as data center, the deep detail about information, that is deep depth knowledge about that data that is acquired, and then share and communicate. Share and communicate means how we want to share that information to the end users. Or data archive, data retrieval as well as reuse or destroy, whether we need to use that data for further use, or it is not necessary means just we want to delete that data. So these are all the steps in that data management life cycle. So each and every thing happens next for next batch of data. If it is real time, batch wise or stream wise, whatever the data acquired, this data management life cycle will happen. Okay. So in the data management life cycle, data dissemination and the data aggregation is plays important role. So here we know that sensor node in that IoT having the limited capability to process the data because it have the low battery power. So automatically the lifetime for that sensor, it is depending upon how much power it has. Actually, already I told that in that sensor, in that IoT network, the sensor depending upon the sensor battery power, that uh, restricts the lifetime of the whole IoT environment. Here, the data aggregation and the dissemination that plays important role to increase the lifetime of the sensors. Okay, so how it is done means it is just eliminate this data aggregation and dissemination. This process eliminating the redundant information from the sensors nodes, that is data aggregation, and it forwards to the needy information to the base station destination, or so this process is called data dissemination. So different data aggregation as well as dissemination techniques as well as algorithms are introduced depending upon how the sensor networks are arranged in that particular application in the IoT environment. So the structure of that there are different structures, sensor network structures that plays important role in that lifetime of the IoT for this IoT data management. So this is the flat networks. There are different kinds of here how the sensors are connected in the network. Okay. So this arrow mark not represent just the data are moving from this into this, like that only. This actually not wired connections, just for representation only here mentioned. So in this flat network here, each node having the same battery power. The flat network is each node have the same battery power. Each have each nodes are having powerful node only. Okay, each node have same power as well as this. This is the powerful node. Okay, so here what happened means it actually if you take this is for example source node. Okay, it is just to give the information, that is it is just to give the information to the each and every nearby nodes. Okay, whatever information it have, it is just to give the information to the nearby nodes. So this node have only single node, nearby node, so it is just like send like that. So in that thing, the informations, all informations are moving from all the node to sync. Okay, here this all the here there is no head, that is leader sensor or node sensor, that is header sensor, not like that. All sensors are just send the information to the thing. So here automatically what happened, unwanted communication, if whether that sensors informations are record not, whatever it is, but it is not considered, just it is send information whatever it has to be nearby and finally to the sync. So due to this unwanted communication, and actually for unwanted communication as well as excessive computation burdens, okay, actually what happened, here the sync get burden as well as it takes more time. Actually what is record information need to send to the further. So automatically it happen here, the battery power get lower. Okay, so this is the step by step process, just we have like this. So in order to reduce that burden as well as in order to next reduce that battery power, how we want to arrange these nodes. Okay, so this is the decaying performance in the sync node. Actually this affect the whole network, sensor network functionality. So depending upon the application, there are different protocols can be used. Okay, so in this flat network, depending upon your application, different protocols are used. These are the protocols used, how the data are transmitted. Flooding protocol, gossiping, sensor protocol for information via negotiation. That is SPIN, directed diffusion, one phase full diffusion, reamer routing, gradient based routing. So these are all the different protocols used in the flat networks. That is, flat network means all the nodes are having, all nodes are powerful. Okay, so it is just transmit whatever it is just give the information whatever it is sent to the nearby nodes and finally to the sync. So like that it have the sensor architecture, network architecture. So for this architecture there are different protocols are there. So for this dissemination and as well as aggregation. So in this flooding, what it is actually do. So in this protocol, a source node, here the yes, actually this is source, this is destination. So we need to uh, send the information from yes to the source to this destination node. So in this flooding protocol, actually a source node broadcast the information to nearby nodes. So actually this is just the flat network, isn't it? So it is just to broadcast the information to the green. So that's why I mentioned this as the green thing. Okay, and this is violet. It will transfer like this. Okay. So it is just a copy of that information to nearby nodes. It is taken like that. Okay, when destination receives that information and it does not, if it is actually this is actually destination in this at that time, if it is destination means it does not transfer the information or broadcast the information to nearby. Okay, they just receive that information. Okay, in the two sides the informations are passed, copy of that informations are passed. If it is reaches the destination should not pass that information to nearby. So that's why here in this destination only it receive that information, it does not transmit. So that's why this is like flooding, the informations are passed. So this is the here energy consumption, because each and every time it need to send copy of that. If suppose here if we have one more node here, like one more node here means again need to send that copy of that information to 3 nodes. So automatically the energy consumption is here more. So it is data forwarding. Actually, data consumption is more means automatically there is the possibility for sudden failure to operate and a collapse in the data forwarding. That is important thing here. And then gossiping. So gossiping, we know that from the name itself, it is just the information forwarded to one selected neighbor, and thus it avoids the gossiping means it is just to give the information to the selected neighbor only. It does not forward the copy the information to all nearby nodes. So automatically what happens means there is the possibility energy dissipation is reduced because instead of sending whatever the near unlike flooding we need, it sends the copy of data to all nearby neighborhood nodes, but here it is not like that. It is sent only to the selected neighbor. So energy dissipation is reduced, slowly reduced compared to that flooding protocol. Here the SPIN, sensor protocol for information via negotiation. Here what happened means, here the is this data centric routing protocol. This classified as the push-based diffusion protocol. Here resource adaptation and the negotiation are two main features. In the NAID system, resource adaptation and the negotiation are the very important features in this SPIN. Okay, is the high-level descriptors for metadata. This protocol information is using for high-level descriptors when sensor knows when it is actually find out new data and node advertise. Okay, the new data I have like that. So that informations are mentioned like this. That is dotted line. Okay, so it is just after sensing new data that initiating node advertise or even we told us the broadcast that information to all nearby nodes. Okay, so which node actually want that new data? So that give a request new data to the initiating node. From that, initiating nodes send that new data to the destination node. Okay, so that's why this dotted line represent that advertising with the metadata, and then this color, this orange arrow mark represent the request. Okay, I want that new data. This node tells I want that new data like that. After that, that initiating node, whatever new data it found, that information is forwarded to that requesting node. Okay, so that's why this is here actually it just send one information alone. After requesting that, it request information. So here also there is unwanted information, that is unwanted communication is reduced. So interested nodes, that is the interested nodes only request that. And here the important thing is in that SPIN protocol, each before sending any information or forward that information to the next node, it verify the resource, but it verify the battery power, whether it is enough to transmit uh, that information to the next node. So this is very important thing, important feature in that SPIN protocol. So that's why it is the resource adaptation. Why it is called resource adaptation means before um, doing any data forwarding operation, it is just to verify the resource, that is mainly battery power, and then it do the forwarding operation. If it is battery power is low means then it cannot complete that task. This is the directed diffusion from the. So actually in the directed diffusion, this is also data centric application specific protocol. In this directed diffusion, there actually the sync request, that is the destination request the information by broadcast. Just inverse to that of that one. it just sync request the information by broadcast. In that previous case, spin actually source, that is the initiating node, broadcast or advertise, I have new data like that. Here, the sync request information by broadcast, the interest in the network. Next, the interest describes it requires the network is implemented. Depending upon that, the geographical area sync, init ID, interval, and duration are the attributes that are used in that define the interest. So each receiving node in the network derives the gradient from the interest. Gradient means what is the distance? What is the distance between that sync and that particular node? If it is okay with that gradient, depending upon that gradient level only, it will move the data to the forward condition. So that's why directed diffusion. The data is forwarded depending upon the distance, that is whether it is no latency, that is time required to forward to that endpoint. What about that? How much resource are required? So that depending upon that only, this will be happen. This is one phase full diffusion. In that protocol, in the directed diffusion protocol, there is many sources as well as sinks are not possible. But in the directed diffusion protocol, it's not applicable to the network with the many sources as well as sinks. This one phase full diffusion, this is eliminate the gradient reply link. Okay, just it eliminates that gradient reply link to that sync as in direct diffusion protocols. So just it give the interest request message by sending established gradients, and from that sources, it is if it is not send the gradient reply link, and then it only transmit the information with the low latency. That is, it just eliminates that descendant and it will give the information with the low latency. So some minimum transmission time. Okay. So this one phase full diffusion is used to control the network with many sources and sinks. That is an important thing, but it is not in the case of directed diffusion. So here energy conservation of each node is reduced because it doesn't it actually eliminates the gradient reply link. So automatically the energy conservation for that message, okay, that it actually in the previous directed diffusion, it actually find out that gradient and then it send the interest message, but it is not like that. It just eliminates that gradient reply link. So automatically the energy conservation for that process is reduced in each node. This is the rumor routing. So it is rumor routing is just a small change from the direct diffusion protocol. It is just between flooding and even flooding. When a new node sensor node is find new event, then event is listed in table. So from that one, the rumor routing utilizes the agent which is long-lived data packet. So it is just whatever the listed new event are listed in the table. So actually it find out the agent for each and every event. So which agent is suitable to transmit which information, that is also allocated in that table. So depending upon that, the sensors nodes are the information to the particular sensor nodes are forwarded. So by using this, actually energy efficiency is increased. Okay, so it is just to find out um, the table is for allocated with the new event list with the agent. Agent means which node is enough to transmit that data to the end user. So to the destination node. So like that, it formulate the table. So it is easily it actually this routing protocol is energy efficient. This is the gradient based routing. This is kind of directed diffusion protocol, because in the directed diffusion protocol also that router, so sorry, that sync transmit the information regarding the geographical position, and it find out the how much period it takes, that is gradient is calculated. So for this gradient based routing, what is the objective is to improve the lifetime of the network. How it is improve the lifetime of the network means distribute the traffic, that is distribute the data dissemination uniformly around the forwarding the data uniformly in the network. So here each node of the network can calculate the number of hoops to reach the sink. So each and every nodes find out how many jump, that is how many hoops need to reach the sink. So depending upon that difference between one node to another node, you find out how many n values. So the informations are forwarded depending upon how many path of highest gradient. The informations are forwarded in the path of highest gradient. Highest gradient means what is the most difference. For example, one node is it required the destination by 3 hopes. Another node is required 4 hopes means just it pass that information through the node with the 3 hopes because it requires less time as well as power consumption for that node is reduced. So like that, by using that feature, we can reduce the energy consumption as well as latency, that is time required to reach the destination. Automatically the whole thing it will be reduced, it will be used to reduce the lifetime of that IoT environment. So this is just a summary of that each and every protocol with the merits and the demerits. So in that flooding protocol, this is very simple. Just to give the copy of that information, whatever it have, that it just pass it to the neighborhood here. But the demerit is energy consumption because all the nodes are transmit whatever information they find out, it is just to transmit. So automatically the energy consumption is moved. The gossiping, here the no implosion as well as uh, decaying of energy. Compared to the flooding, gossiping, the energy consumption is better, but it takes more time to reach destination. The for that spin in that protocol, no explosion but low energy consumption than this flooding protocol because here it just to find out what is the uh, important thing is how much power it have as the backup. So the nodes are find out that power backup, then only it ready to forward the data to the next node, that is energy aware nodes. So here I mentioned that energy aware nodes. So that's why this is very important feature. So here the energy consumption is less compared to this. So here the inability to guarantee data delivery. Suppose and then direct diffusion. Here the low implosion, and then low energy consumption than flooding protocol. All these protocols are low energy consumption for this one. And then this directed diffusion only applicable to the network with a few sinks and base stations. And then this one phase full diffusion, this is not like that. We can apply this or more number of sinks and base stations. There no explosion. Here the low energy consumption than DT compared that because here it eliminates that latency link information. So sorry, gradient link information link. So automatically the energy consumption is less than this direct diffusion. This is applicable to the network with the more sources and the sinks. This is one of the advantage, but it is not in the case of direct diffusion. Okay, here we can use more number of source and the sinks means automatically we need to have control over different over this number of source and sinks. Number energy efficiency as well as no explosion. Gradient based routing, it improves the network lifetime. So these 7 different protocols are used in the hierarchical flat networks. Next network is hierarchical networks. So in this hierarchical network, this is also called as cluster-based network. This network is called cluster-based network. Here, actually, what happened means the total number of nodes, the whole nodes are divided into number of clusters. Okay. While data aggregation, the data fusion process is performed in each cluster by cluster head or otherwise threshold head. Okay. Here, actually, this is sync node we have. Here, the sync. These are different uh, nodes. Okay, different nodes are there. So in each and every cluster there is one powerful sensor node is there, that is represented as the green. This yellow color nodes are represent normal sensor node. Okay, this green color uh, represent powerful sensor node, and the yellow color represent the normal sensor node. Here energy efficiency is achieved by unwanted communication, because each and every time in that flat network either we need to copy or forward the data to all neighborhoods, or otherwise we need to give one negotiation, or otherwise we need to give one advertisement to the SIM group, all the nodes like that we need to give more data forwarding methods in if we connect all the nodes in flat network architecture. But if it is hierarchical network architecture compared to the flat network architecture, in this hierarchical network architecture, the computation burden is reduced as well as the energy efficiency is improved. How it is means unwanted communication is reduced. Okay. Each and every informations are passed only through the powerful normal sensor nodes are give information to the that powerful sensor node, and from that powerful sensor node it reaches the sync. Okay, so here this brown color represent multi-hop communication, and this one represent single hop communication. Single hop means only from this node to this node. From this node to this node, there might be more number of nodes may be existing between, just for represent. Multi-hop means there is not a simple jump. Okay. Compared to the flat networks, in this radical network, the energy efficiency improved by eliminating the unwanted communication, as well as the computation burden is also reduced if the sensor nodes are connected in the hierarchical network architecture. This is the schematic architecture for hierarchical network. So this is one of the protocols used in that clustering network or otherwise hierarchical networks. So here, low energy adaptive clustering hierarchy, that is LEACH, is the first clustering protocol. Actually, this protocol is suitable for continuous monitoring and the data reporting. So, depending upon that, we need to choose this one. If for continuous monitoring applications, this LEACH protocol we can use. The LEACH protocol has the two phases: setup phase and the steady phase. In setup phase, what are the things we need to consider? So, in setup phase, the sensors are arranged as the clusters. We need to arrange the uh, uh, clusters in the nodes in the cluster format, and we need to choose the cluster head. For each and every cluster, we need to select the cluster head, which is the powerful node in that cluster. In that setup phase, these are the things we need to state. And that steady state phase, it involves the data aggregation in that cluster head, data aggregation or data dissemination process. In that cluster head, transmit the data from cluster head to sync. Okay. In that setup phase, need to set up the clusters with and need to initialize the cluster head, and then in steady phase the data are forwarded to the from cluster to sync. So this procedure, here the predetermined function, P is the predetermined function of the nodes in the cluster, R is the random number between 0 and 1. How to calculate the threshold value for that sensor node means just Ti is equal to P divided by threshold value for that ith node. P divided by 1 minus P, or of mod of 1 by P. So just we need to compare this random number or then the threshold with the threshold value Ti. If R is greater than the threshold value, then ith sensor is chosen as the cluster head. How? So by using this, we need to select the cluster head. How to choose the cluster head in that cluster? By using this expression. So depending upon the cluster head selection, the leech protocol extended as the how we choose the cluster head. So depending upon that, that leech protocol is extended as energy leech, that is E leech, two level leech, that is TL leech, M leech, that is multi-port communication leech, and then leech centralized, leech C, leech centralized, vice cluster head leech. So each and everywhere from the name itself, we can get some idea about what kind of how it is extended in that hierarchical or cluster architecture, cluster network. So in that hybrid energy efficient distributed clustering approach, this is the next protocol in that um, hierarchical architecture or network cluster or network. So here the main objective of this hybrid energy efficient distributed clustering approach is to improve the lifetime of the network. How it is improve the lifetime of the network means to just identify the cluster which how enough proficient, that is efficient to just establishing the clusters with the more capability. So in that heap protocol, each node in the cluster needs to calculate the probability. So each node in that cluster need to calculate the probability value Pi is equal to C into E residual divided by E max. C is the initial percentage of the cluster head. E residual is the residual energy, that energy of that node. E max is the maximum energy level at the initial stage. Okay. So present, depending upon the present residual stage, the probability of this ith node will be varied. If it is high means automatically the probability of that node will be increased. So depending upon that, it is the probability of this value, it is selected as proficient, that is capable node. Okay. So that is it plays important role in that one. Okay. Depending upon the probability value, that at present, what about the power backup for that node? If it is high, means the probability value become high. So then it is selected as the cluster head. If it is equal to 1, then it is selected as the cluster head. If the probability is less than 1, then it is considered as the tentative. Less than 1 means it is considered as is not confirmed. We may think that is the cluster head for the next thing. Like that, depending upon the probability value, we make it the Q. Which one is next to consider as the how much percentage it is possibility to consider as the cluster head. So that only you need to mention percentage of the cluster head. How much possibility to make that as the cluster head. Okay. So this value is used to select the cluster head. And then next protocol is clustered diffusion with the dynamic data aggregation, that is CUDA. This is another third protocol approach which is used for the hierarchical architecture or cluster network. This is the hybrid approach which combines the process of aggregation as well as diffusion. Both the things are combined here. It is possible for adaptive data aggregation in unfamiliar. If it is element is new, that is also adapted to this. This protocol is adapted to that new environment. Here, uh, this here the catch information having about information about the node where the data need to aggregated as well as the address of the neighboring nodes. All the details are in the catch information. The query catch is having all the information regarding the node as well as what about the address of that neighboring nodes. All informations are present in that clustered diffusion with the dynamic data aggregation. So these mainly these three different protocols are used in that cluster network, that is hierarchical architecture. Um, for that type of network, the sensors are connected means these are all the merits and the demerits. And if the nodes are connected in chain-based networks, then how the data aggregation taken place? In cluster-based network, the cluster here, this is the sink. Okay. In the cluster-based sensor network, cluster head is furthest distant from the sensor. Then, if suppose in the cluster-based, if it is furthest distant, means automatically it takes more energy as well as it takes more time to reach that thing. So instead of sending between them, so further improvement in energy efficiency can be obtained by using this thing. Okay. If suppose in that hierarchical network architecture, here, for example, it is to be given the 5 nodes. Actually, there might be a number of nodes in that one. Okay, in that outer layer of that one, there is it requires more time to reach that node. Okay, directly it gone for single hook. It is not possible to reach that. There are different in outermost layer. If it is that means it takes more time to forward the data, its data to that header. So at that time, energy efficiency is also reduced. So if it is connected in chain based, so automatically that will be reduced. So the further improvement in the energy efficiency is obtained by using chain based data aggregation technique. Here, the sensors just transmit to the close neighbors. So the chain between is represent, this is the source, this is the sink. It is just reach the sink. So in that, this is the power efficient data gathering protocol for sensor information system. Okay, Pegasus. Pegasus, this is the powerful protocol used for data aggregation for in the chain-based network. Okay. So here the greedy algorithm. Here the greedy algorithm is used to form chain by determining nearest sensor nodes. Okay. So instead of finding, so this node find out greedy algorithm to find distance between these two neighbors. This is compare this. This is the nearest neighbor. So it will select this spot. Again, this node find out which one is nearest. So depending upon that, it forms the chain and it reach the and it will reach the sink. Okay. So here, what happens in this network, all the sensors having knowledge about the whole network. So during the aggregation, the information transmitted to the closer nearby sensor, which receives the all infused data. Okay, and the infused data is retransmitted, that is to the next closest nearest sensor, and until it reaches the reader or it reaches the sink. And then tree-based data aggregation. This is kind of chain we can apply. This is instead of this chain aggregation, here the tree-based network, the sensors are connected, how the data are forwarded. Here the sensor nodes are arranged as the tree. Here this one represents root node. This is the target node. Okay, so remaining are branch node. Here the sensor nodes are arranged as tree. So that's with the one root node and the remaining are branch node. Here the branch nodes are just to aggregate the data and to transmit the data to the useful data to the root node. Here the main objective is to develop energy efficient data aggregation tree structure. So here the tree based data aggregation is suitable for in-network data aggregation only. Okay, this is the grid based data aggregation. Here, the sensors are clustered in either rectangular or square shape. Here, sensors are connected in the square grid. Here, rectangular grid. Either here, this color, this purple color represents aggregator, remaining are sensor. So, you just collect the data and given to the finally sync. Okay. So here, in this grid network, each and every lines are to form a series of square or rectangle. Collection of nodes are connected either with a grid of rectangle or square. So in this grid-based data aggregation technique, a set of sensors, all sensors in each grid are assigned one instead of mentioning one leader in the cluster. In that cluster-based network, just we assign the leader instead of here we mention as the aggregator. It aggregate information and send it to the final sync. It is just nothing but leader in the group header node header in the cluster based. Instead of that header, here we use as the aggregator. So this is suitable. This kind of data dissemination and aggregation, this kind of network architecture is suitable for mobile environments. So these are all the how we can the data is forwarded for different kind of sensors network architecture. So that's only we discussed. So how the energy efficiency, what is energy efficiency, how we can improve, as well as how we can increase the network lifetime and data accuracy and latency, the time period to reach the destination. All those things are improved how the sensors are connected and how the data is forwarded through. That only mentioned here. So what is the network lifetime? It's just a number of data aggregation rounds. How many rounds the data aggregations are present? Percentage of sensor. How? In terms of percentage of sensors. So until the sensors die. So the sensor, each and every, we know that each and every sensor have its own power backup. So until that, so for example, if we have a 10 sensor for particular applications, so the network like at least 5 sensors are required to move on that data cycle to the end user, means we have to maintain 50% of the sensors. Okay, after that, if 6 sensors are died, 6 sensors powers are goes down, only 4 sensors are in the operational condition, means at that time the network lifetime is not exist. Okay, so each and every applications there are there is also some kind of percentage of sensors are there that is enough to maintain that applications. Okay, until that is the network lifetime. So depending upon that sensor lifetime only, the whole IoT environment plays important role. So how the data are generated, as well as the generated data are aggregated and disseminated to the final end user, that is it plays important role in that whole power consumption of the sensor, as well as the power consumption of sensor plays vital role in that network lifetime. So that's why this is data dissemination and data aggregation plays important role in that whole IoT lifetime environment. So these are all the advantages of this data dissemination and aggregation. Yes, both are used to improve the energy efficiency of the sensors. It is used to decay the traffic of the IoT sensor network. It also improves the accuracy of data which is collected from the whole IoT network. And then data diffusion and data aggregation process is used to reduce the redundant data collected from different sensor nodes. So these are all the advantages of this dissemination as well as applications. So these are all the references. Thank you. Krishna Kumari, are you there? Any query?